We're going to continue on in Unit 1, and we're going to discuss atomic number and mass number. Previously, we had talked about atomic structure and the subatomic particles, protons, neutrons, and electrons. So remember, I gave the example of aluminum. If you had an excellent pair of scissors, how if you kept cutting this piece of aluminum foil smaller and smaller, you would reach a point where you could no longer cut it and it would still be recognized as aluminum. That's when you've reached the atom. And atoms differ from one another according to how many protons they have. So carbon is carbon because it has 6 protons. It's kind of like, that's its identity. If it had 7 protons, it wouldn't be carbon. If it had 5 protons, it wouldn't be carbon. So if you look on the periodic table, which is on the inside of your book, you will see that carbon has a number of 6 listed above it, and that is the number of protons. So 6 is listed. So remember that protons, so 6 protons, remember they have a +1 charge. And electrons have a -1 charge. So carbon has 6 protons and 6 electrons. So +6, -6, overall the charge on carbon is 0. So this brings us to our first definition for this lecture. Atomic number is the number of protons in an atom. Elements in the periodic table are arranged in order of increasing atomic number. Every element has its own atomic number. For example, carbon has an atomic number of 6. All carbon atoms have 6 protons, and any atom which has 6 protons must be a carbon atom. Since atoms are electrically neutral, the number of protons is also equal to the number of electrons. So this is the number of protons in an atom. It's also equal to the number of electrons in, and I'll say in a neutral atom. Okay, mass number is the mass of an atom and is equal to the sum, excuse me, okay, I think I'm done. Mass number is the mass of the atom and is equal to the sum of the protons and the number of protons and the number of neutrons. Remember that protons and neutrons are the ones that have mass, while electrons are negligible. So it's the sum of the number of protons and the number of neutrons. So if you look on the periodic table, under carbon, you will see this number here, 12.0107. That is the atomic weight. So it's not the mass number. So atomic weight listed for carbon on periodic table. The atomic weight is slightly different than the atomic mass. The atomic weight is kind of like your class average in a class because it factors in isotopes and percentages of isotopes. Kind of like how some classes weight the exams at 60% and quizzes at 10% and finals at 15%, whatever your class structure may be. The same is true for atomic weight. So there are certain amounts of carbon-12, carbon-13, carbon-14 that are found naturally, and that is factored into the atomic weight. So the mass number for carbon, when you're filling out a table like this, it has to be given, or you figure it out, or add protons plus neutrons. It is not on periodic table. So when you fill out these tables and you find yourself entering non-whole numbers, like if you started to enter the mass number is 12.107, then that's incorrect. You are not supposed to get it off the periodic table. I say that about 100 times, and my students, I know, get tired of it. But I've had so many students make that mistake that I feel like it's my job to tell you, do not get the atomic mass off the periodic table. That is the atomic weight. Okay, so how many neutrons are present in carbon? I'm going to change this. I'm going to say carbon 12. Now, when I say carbon-12, this is the mass number. So if I know the atomic number of carbon, so the atomic number, pull that up off my periodic table, that's 6. Mass number I provided for you is equal to 12. So the number of neutrons is equal to mass number minus atomic number, which is equal to 12 minus 6, which gives you 6 neutrons. All right, fluorine has an atomic number of 9 and a mass number of 19. How many protons, electrons, and neutrons are present? So let's see, protons, neutrons, electrons. So protons would be the same as the atomic number, same with the electrons. And then the mass number is going to be 19 minus 9. The number of neutrons is going to be the mass number minus the atomic number, so you'll get 10 neutrons. Okay. So these tables, a lot of times students make more difficult than they need to be. They can be easy points, straightforward. I highly encourage you to just practice these. They look really intimidating, but actually it's pretty straightforward. So let's work this practice one together. You'll need a periodic table nearby. There's one on the front cover of your book, and you can use that for your exams. That would be plenty. Also, there are many available online. Okay, so I have given you enough information to fill out the rest of this entry on the table. The atomic number is 26. From the atomic number, I can get the protons and the electrons. So this is 26, 26. The element, I'm going to have to look at my periodic table, and I look for atomic number 26, and there is iron. Okay, and then the number of neutrons. I have the mass number. No, I'm not going to the periodic table to get the atomic weight. So 56 minus 26 gives you 30. So you have 30 neutrons for iron. So I want you to hit pause and work through the rest of these. Again, you can use your periodic table, and you will be allowed to use your periodic table in exams. It would be hard not to use the periodic table. And I'm not one of those crazy instructors who makes you memorize your periodic table. That's just crazy. All right, so hit pause, work through these, and we'll go over them in a second. Okay, so the second entry on the table is chlorine, atomic number 17, mass number 35, 17 protons, 17 electrons. The next entry is silver, atomic number 47, 47 protons, 47 electrons, and a mass number of 14. That doesn't look right, does it? I think I made a mistake there. Your mass number would be 47 plus 61, so that would be 108. Okay. Good to double check your answers. The next one, aluminum, 13, 13, 13, 27. That's good. And then the last one, phosphorus, 15 protons, 15 electrons, 16 neutrons. All right, so on the next page, we are going to talk about isotopes. And I briefly mentioned this when we were talking about atomic weight. Okay, so isotopes All atoms of a given element contain the same number of protons. So the atomic number is characteristic. Remember, that's what we're saying, that when you have 6 protons, you're always carbon. The number of neutrons can vary. So isotopes are atoms of the same element, but different numbers of neutrons. Different number of neutrons. So I'll say same atomic number, different mass number. So when you hear about carbon-14 used for radioactive dating, it's still carbon, it's just a different isotope. So instead of having a mass number of 12, it has a mass number of 14, so it has a different number of neutrons. So let's look at hydrogen. Hydrogen has 3 isotopes. The number of protons are the same, but the number of neutrons differ. Which number is affected? Atomic number, A is the abbreviation for atomic number, or, oh sorry, I always get these flipped around. Mass number, and then Z is atomic number. Okay. So if you look the atomic number up for hydrogen, it's the first one listed on your periodic table, so it's 1. So all of these are going to have 1, 1, 1. And this first one would be hydrogen dash 1. Now, when you see them written like this, this is the mass number. Okay, so the mass number here is 1, hydrogen 2 is 2, hydrogen 3 is 3. So the number of protons in all of these and electrons will be 1. Okay, to figure out the number of neutrons, you're going to take the mass number minus the atomic number. So 0 neutrons in hydrogen 1, 1 neutron in hydrogen 2, that's 2 minus 1, and then 3 minus 1 here gives you 2 neutrons. So what varies is the mass number. So A is what varies, the mass number. A common abbreviation you will encounter is shown below. So you have the element abbreviation, and then you're going to have the mass number here and the atomic number here. We use this a lot with nuclear chemistry, which is coming up. So uranium-235 is commonly used in nuclear reactors. How would you write its abbreviation? Okay, so remember, this is the mass number. Okay, so write it like that. Now I have to look up the atomic number of uranium. And uranium is way down here. So it's 92. Okay, this is what I mentioned earlier. Most naturally occurring elements are a mixture of isotopes. Atomic weight represents an average including isotopes, just like your average in a class. This is why hydrogen's atomic weight on the periodic table is a little greater than 1. So if you look at the periodic table, this number on the bottom is the atomic weight, so it's 1.00794. So that means there's a lot of naturally occurring hydrogen 1, but there's also some hydrogen 2 and hydrogen 3. Now on the next page, I have another table for you to fill out, and you're going to fill it out just like we did on the previous page 11. Instead of having element, it has isotope, and you can just write the symbol, like Cl for chlorine. Let's work this first one together. So if you look up atomic number 5, that's boron. The atomic number is 5, the electrons would be 5. Protons plus neutrons would be 12. So it's just a little different mass number than what you'd find naturally occurring. That's what makes it an isotope. So I want you to hit pause, work through the rest of these, and then we'll go over them. Okay, so you have oxygen, atomic number of 8, 8 protons, 8 electrons. Next one is phosphorus. This would be phosphorus 32, 15, 17, 15. Chlorine, atomic number of 17, 17 protons, 17 electrons, 19 neutrons. And then another chlorine, different isotope with a mass number of 37, but still has the same atomic number and electrons. So we will stop here for this lecture. I want you to go on and work your practice problems, your homework problems, and take whatever quizzes are needed. And I'll see you next time.